Hey y'all, in this video we're going to talk about trapezoids and we're going to derive some of the special properties that exist in trapezoids. Once again, using what we've learned in the past, this time about parallel lines and triangles. So to do a quick refresher on what a trapezoid is, remember it's a quadrilateral with one set of parallel sides. And trapezoids have bases. We call those parallel sides the bases. So this would be like base 1, and this is like base 2. Let's go back to our work with parallel lines. If I were to extend the parallel bases out or sides out, I would get, of course, parallel lines with one of these other sides being a transversal, right? And we know what transversals do. They give us a bunch of congruent angles. So I know that angle A is congruent to this angle here, right? I'm going to label this angle 1. I'm going to label this angle 2. I'm going to label this angle 3. Okay, so I know 1 and 3 are congruent. And I also know that 2 and 3 form a linear pair and are therefore supplementary and add up to 180, right? And, I can say, since 1 and 3 are congruent to each other, that 2 and 3 are supplementary, I can now, by substitution, by subbing in the 3 for the 1, I can get, or the 1 for the 3, I get angle 1 and angle 2 as being supplementary. That is the first trapezoid property. The two angles that are adjacent to one another, right, that are actually inside the bases, right, they are supplementary. Now, plain old trapezoids are, they don't give us a lot. What's more interesting are the isosceles trapezoids. Now remember, an isosceles trapezoid is a trapezoid where the non-parallel sides are congruent to one another, and this thing has some pretty cool properties. So first, I want to add something in. So once again, I don't have enough line segments to prove anything. And so let's go back to constructions and constructing the shortest distance. So if I want to construct the shortest distance between the two parallel lines, right, I can do so, right? I can just say construct the shortest distance, right? And the shortest distance, remember, is the perpendicular distance. Well, okay, now this gives me some stuff here. Since these are parallel lines, and parallel lines in our type of geometry are always like equidistant from each other, I know that these two shortest distances have to be the same distance, right? And so I have an angle, a right angle, a side, which happens to be a leg of a right triangle, and this side here of the isosceles trapezoid, which I can call the hypotenuse of this right triangle here, right? I can say that these two triangles here, like let's give this a letter. Let's go with E and N, okay? And so C, K, E, and H, I, N are congruent triangles by hypotenuse leg. Now we didn't actually use that a lot when we had that congruency introduced, but I use it here because this is the hypotenuse of a right triangle. That is the legs of a right triangle. I have two right triangles that have congruent hypotenuses and congruent legs. It means I have two congruent triangles. And by congruent parts of congruent triangles, I can say angle K is congruent to angle I. And so in an isosceles trapezoid, not only do I have these sides being congruent, I have those two angles, which are called base angles, are also congruent. Now, it so happens that if I kind of logic out this a bit, these little angles up here are also congruent to each other, and these two angles are also like right angles. And so I can use angle addition to show that this trapezoid angle C and this trapezoid angle H is also, they're also congruent to one another. Now finally, I have another isosceles trapezoid that I have this time named Yoda. And I drew in the diagonals. And there's something special about the diagonals of an isosceles trapezoid, which you may have thought about before, this may have come to you before. Now that we can prove triangles are congruent in corresponding parts and all that stuff, we can actually prove that what's special about these two diagonals. Now, these are overlapping triangles, and it might help you remember to draw out the two triangles. I know that YA is congruent to OD because it's an isosceles trapezoid. And I also know by the reflexive property, AD is congruent to itself. Chink, 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 chink. And I previously logicked through those base angles being congruent. So I know, chow, that angle is congruent to that angle there, chow. And so what I have by side angle side are two congruent triangles. Now, YD and OA are the diagonals. So therefore, by corresponding parts of congruent triangles, I have that the two diagonals of an isosceles trapezoid are congruent. So now let's get down to the actual conjectures themselves. So C39 is the trapezoid consecutive angle conjecture that says the consecutive angles between the bases of a trapezoid are supplementary. Remember, that's where we use the parallel lines cut by a transversal. Isosceles trapezoid conjecture is C40. It says the base angles of an isosceles trapezoid are congruent. And remember, this is where I dropped those two shortest distances, which were perpendicular, gave us two congruent right triangles by hypotenuse leg. And then by corresponding parts of congruent triangles, I had base angles were congruent, right? And then C41 was the isosceles trapezoid diagonal conjecture. You can construct those diagonals by the line postulate, and then you can separate out those two triangles and prove that they're congruent. And by corresponding parts of congruent triangles, those diagonals of the isosceles trapezoid are congruent. Now, it's only isosceles trapezoids, not regular ones, isosceles trapezoids. So you can kind of assume, what are we going to have to do? Well, I need you to go back again and add the drawings into these conjectures, right? Make sure they are properly marked, okay? Because it's going to help you later on when you're asked to, I don't know, prove those conjectures are true. So I need you to consider that too. Go back through, map out the logic on how to prove those three conjectures.